Welcome to another Skill Me Up session in our Expert Talk series, where today I'm going to talk about Azure and the love for Terraform, and on the other side, how Terraform as a non-Microsoft product also provides some nice integrations with Azure. As a starting point, a little bit about myself. So my name is Peter Detender, based out of Belgium. If you might notice that from the accent, I'm sorry for that. But quite passionate about Azure in meantime, where before Azure, I was known as an overall Microsoft data center expert, so deploying Microsoft server technologies in traditional data centers. And with the world somehow shifting to cloud about 10 years ago, I decided to jump on that wave and initially using my Exchange product background to move to Office 365. And once I was in, I would say, the cloud mindset, I took a little leap into the Azure world at that time, talk about like 7, 8 years ago. And I somehow found a new love and decided to stick in the Azure world. And in meantime, for almost a year now, I'm working as a Azure technical trainer within Microsoft, part of the EMEA team, but it's a global team within Microsoft. And what we do is providing Azure readiness to customers and partners. But before that, I was running my own business and also provided some content here on the Skill Me Up platform. And that's where every now and then I still try to participate in some more, I would say, community-minded webinars like this one, where I can still talk about Azure, I can still talk about my passion domains, and that's what I'm going to try to inspire you with today as well. So a quick overview, what we're going to cover, starting with a little bit on infrastructure as code, which means that using automation templates in Azure, or if you want other clouds, but I'll talk about it later on, you're going to automate the deployment of your cloud-based resources. And within Azure, we do have a concept called ARM templates, Azure Resource Manager templates, which obviously is good enough, but there are a couple of other mechanisms to go through, and that's where Terraform comes in, where I'm going to walk you through the high-level overview, what is Terraform and how you can use it. And once you know like the real motivation, the argumentation why using Terraform, I'm going to walk you through the basics of the product. It's a lot more than what I can show in like a 45, 50-minute session, but at least should give you a good idea about the capabilities. And then where it becomes really interesting is in the last second two parts, where I describe it as the best of both worlds, which means that we're going to take all the cool things from Azure, all the cool things from Terraform, and squeezing them together. And then closing, since we're talking about infrastructure as code, which typically means automated deployments, walking you through one last demo, how you can integrate Terraform as a non-Microsoft product into Azure DevOps to provide you something like a CI/CD pipeline, for example. I do have Q&A at the end, and we should have a little bit of time at the end of the session to cover your questions, but don't hesitate to send them in already during the session. I'm not really going to jump back and forth in the GoToMeeting tool, but at least then I know that some questions are coming up, and definitely taking time to close them within the next 60 minutes. So starting with the basics, what is ARM templates? What is infrastructure as code? So in short, infrastructure as code refers to managing your infrastructure components, which can be traditional storage, networking, virtual machines, but it's not related to infrastructure itself. So if you're moving more and more towards a cloud model and you start deploying containers, maybe using Kubernetes on Azure, maybe using Azure Container Services, using app services, but also deploying SQL Azure, deploying MySQL and other non-specific infrastructure components. And I know it's sometimes a little bit a confusing topic because it's highlighting infrastructure. So the assumption is that it can only deploy traditional infrastructure, but it's a lot broader than that. And the main idea is that you're going to use a descriptive model. And that means that instead of just going out and deploying the baseline, the virtual machines, the storage, the networking, web app services, functions, anything else, you're going to repeat the same process over and over again. So you're going to work towards creating a template. And one of the aspects of using templates is idempotence, which means that whenever you deploy it, the end result will always be the same. Obviously, assuming that the template is working fine, and meaning that the backend shouldn't be changing that much. So it obviously still means that you need to update your templates whenever something's changing. But the baseline is that the outcome, if you deploy a template and you're going to deploy a single virtual machine with everything around it, you're going to destroy it, you run the same template again, that's producing the same outcome. Another aspect of infrastructure as code is what we call immutable. And that means that you can run the same code over and over and even easily switching to different environments, like using a template, deploying it to a test and dev environment, but also moving the same template to staging and maybe just replacing some parameters and variables in the template. And why not reusing like 95% of the template and moving it to a full production environment? So only making minimal changes. And then last, lights out deployment. It's what I'm going to show you all the way at the end in the CI/CD pipelines in Azure DevOps. It means that we're going to automate everything end to end. So first, quick demo on what is an Azure Resource Manager template and how we can use it. If my mouse is supporting me a little bit, it is, but it's a bit slow, but that's perfectly fine. So I'm using Visual Studio Code as my editor. It's not the only option you have, but it's at least a real decent one, and you can extend it with the JSON file extension, and it's actually providing you some nice integration like syntax detection using some colors and such. Now, if I zoom in a little bit, you're going to see that my template structure is based on a couple of different sections. So I have parameters where, like in this case, I'm going to define some deployment settings, like the location. Next to that, I'm going to deploy my storage account name. So that's an Azure resource blob storage that I'm going to use. And then a bit more down, I'm going to define my actual resources. Now, what we're going to do here, and this is a pretty easy example because we're only deploying one single resource, but you need to know about what we call Azure Resource Providers. So the section up here, this is our resource provider, which means that we know we're going to target the Azure resource backend called Microsoft Storage, and within we're going to target the storage account. When next to that, we need to provide a name, the location, and as you can see, we're going to build up some dynamic syntax, picking up the parameter or variables from what we defined before. We're going to define the SKU name, like what is the flavor of the storage account. And lastly, we have an output section that we're going to use to store the actual storage account name and the URL. I could show you the same for another. There we go. This is another Azure template, so that the high-level structure is about the same. Where now you can see that I'm also specifying my admin credentials, and luckily I'm not going to store them clear text in my text files here. Where now I'm going to target SQL Azure as a database platform, where now it becomes a different resource provider with again a couple of sections and again providing output, but still one single resource. So the next step is deploying this template. So I could go in my Azure portal. I could also use command line interface. I could also use PowerShell and running a template deployment from here. Where it's going to offer me a couple of options, or I could build my own template. That's what I just did. And loading my file. Now again, I'm using infrastructure services as an example, but it's not limited to infrastructure. So if I would build a template to deploy a function service, to deploy web apps, or the other template, my SQL example, it's going to pick it up and allowing me to deploy it. So from here, based on the settings, the parameters in my template, it's going to ask me some additional questions. Obviously, if I extend my template and provide all the settings hard-coded in there, then I can reuse it and it's not going to ask me any questions. The other option you have with ARM templates is doing the opposite, where you start from a already running deployment. So this is my running Azure environment. And what I could do from here is going into any of my resource groups and exporting my template. And this is going to produce me a similar template. There's quite some resources in there, so it might take a little bit of time. And it's producing the same output, but obviously hard coding all the settings. So the fixed name of the virtual machine that I'm using, that I deployed already, will be in there. My load balancers will be in there. The network interfaces will be in there. But nothing would block me from somehow copying over this template file and removing all the specific characteristics, because in the end I can still read out that I'm deploying Microsoft network interfaces, what parameters I'm using. But again, the downside is a little bit that up here, it's keeping track of the actual hard-coded name. And then I need to dive in removing those, but I typically use this concept for creating documentation, because this is an exact state of what I've been deploying before, or literally using it to learn about a new syntax and how I can use it to create a new template. Now, one of the main challenges with ARM templates is that it's based on JSON, and as you maybe noticed, JSON is not really intuitive. It's a pretty complex syntax to actually create those template files. And when I talk to customers, it's always one of the first pain points that comes up, where they love the process, but creating them is actually pretty painful. And the main reason why is because JSON is really good for like computers, but it's not really a human-friendly language. The structure itself can become complex. What I showed you is somehow rather straightforward, because it's one single resource like a storage account or a SQL database. But imagine that you have a similar template to deploy, I don't know, 20 virtual machines together with web app SQL databases, integrating agents, integrating Azure monitoring components and whatnot, like really building a template for your full end-to-end workload that you want to run in one single deployment. Then your template is becoming pretty complex. The authoring process, again, is hard and most of the time frustrating. And we do have Azure Quick Start templates that's available as an open source library on GitHub, where you can find I don't know, a couple of hundred sample snippets out of Microsoft product teams, Microsoft trainers, MVPs, partners, customers, producing their templates and sharing them with the community. But nevertheless, it's still pretty hard to combine all the little snippets of code into what you actually want. Another one that I've been missing for a long time is adding comments into the template, where you can define what is this little snippet in my template actually doing. So you would need to create your ARM template, next to that creating an additional documentation page that actually allows you to, if you share the template with somebody else, that they still know what the purpose of the template actually refers at. Another challenge is that you can have your JSON file, you can have your ARM template, but the deployment itself is only using the deployment state itself to find out if it's successful or not. So there's no real validation before, besides the syntax, like what I showed you in Visual Studio Code. It's going to recognize the JSON format, and if there's a syntax error, but specifically to JSON, it's going to read it out. But if I'm making any mistakes in, let's say I'm defining a parameter region, but the actual parameter setting needs to be location because that's what the Azure resource providers are expecting, then the template is not really complaining about it, unless I'm going to try and deploy it, where then it's going to throw an error message like a known parameter called region, something like that. Another one super crucial in your automated way of working is that there's no real undo feature or even a delete feature, which means if you have a template and you're going to push it out to a resource group deployment, that once the deployment is finished, the only option you have is diving into the resource group and deleting the resource group. But what if you deploy a full resource group container where you have a lot of different standalone Azure resources, where maybe you just want to override an existing one, or maybe you want to delete some parts of it, but not all of them. Then last, it's Azure native, which is not really a challenge, but on the other side, the world is not using 100% Azure. So based on some data that I found out of doing some research with a couple of my customers, and a lot of this information is publicly available anyway, but I think we can all agree that the world today is based on hybrid cloud. And hybrid cloud is valid for about 74% of existing today customers in the Fortune 500, all the way down to smaller SMBs. And there's a good reason why they're using hybrid. It could be because of compliance regulations, data governance, because they have customized applications that might not run on a public cloud, and any other reason that's good for them to have this hybrid setup. Now, hybrid could mean public cloud hybrid, where you're using Azure together with AWS, together with Google Cloud, for example, but it could also mean on-prem environments, existing environments that you want to integrate with Azure. And that's where the Azure templates are not going to help you. So we're still in this mindset of infrastructure as code that's been working really good for on-prem environments, using PowerShell scripts, using other automation engines. Next, we're going to extend to Azure, or if you want, any other public cloud, and finding out that you somehow need to redo a lot of the work. So that was my first part, where I called it somehow setting the scene. So we talked about ARM templates, and again, there's nothing wrong with them. It's obviously a good thing, because otherwise the platform wouldn't rely on them. But there are also a little, some constraints, some challenges, and that's obviously my introduction to Terraform. So what is Terraform? It's, first of all, it's a product. It's a product from a company called HashiCorp, so it's not a tool provided by Microsoft. And it allows for provisioning of infrastructure application resources, so similar to infrastructure as code. But the main difference compared to Azure Resource Manager templates is that Terraform is cross-cloud. It supports on-prem private clouds, public cloud environments, and also integrating with pure public cloud in this multi-cloud hybrid scenario. And that's, to me, one of the biggest benefits. And again, the reason because a lot of organizations are not just running Azure. And I think I can say that it would be nice if the whole world was just running Azure, but we all know that reality is a little bit different, that a lot of organizations are definitely using Azure and are super happy with it, but they're not relying on Azure alone. Next to that, Terraform is using its own language, and it's based on the HashiCorp configuration language, as they call it, the HCL. It's somehow based on Go language, and later on in some other Terraform demos, you will see that the syntax is a lot more convenient to understand to author than what I typically have in an ARM template. And then last, it's covering some of the capabilities of infrastructure as code, but next to that, it can also be extended to become a full resource automation, and if you want, even a configuration management tool. So the next question is already partly answered, like why should we use Terraform? So first of all, because the interface is a lot more natural, which means that developing the authoring process of the templates will go a lot faster. It also results in faster deployments, and it's natively targeting the REST APIs, so you don't need any graphical overhead from the portal. It's all command line based, and that could be another benefit. Another interesting one that I'll walk you through in some of the demos is that Terraform is using a state file. So you start with creating the template, and once you have your template and you're going to run your actual deployment, it's going to capture the state of your deployment. So think back about the ARM template limitations, that you can only validate what's been deployed when it is actually being deployed, where Terraform can help you already validating everything before running the deployment. But once the deployment is done, Terraform is also going to create this little database, if you want, for that particular deployment, and that's what it's stored in a state file. And the other nice integration or capability is allowing you to destroy resources, and you'll find out later on why we talk about destroy, allowing you to remove snippets from an already executed deployment, even allowing you to delete a full resource group deployment or multiple ones, if that should be part of your deployment cycle. And that's something that ARM templates, again, cannot really do as easy as Terraform out of the box. Now, I talked about the easy language, and if you look at these two scripts, it's a quick reflection of what I showed you before in creating an ARM template on the left-hand side for creating a storage account, or using Terraform syntax or the HashiCorp configuration language to deploy the exact same thing, a new resource group together with a storage account, where you can see that even from the code set, it's about 60% shorter in lines. Now, obviously, in developing or authoring, it's not about having more lines of code or less lines of code, but to me, it also means that, yeah, the longer your script file, your deployment file becomes, the more complex, the more vulnerable it is for errors in there. So it's going to make your life a little bit easier. And the other thing we have is built-in support for comments. So you can add a lot of integration directly in your template file as command options. And it's going to make your life so much easier, where now, if you're, I don't know, tomorrow or next week, you want to try out some Terraform demos, like similar to what I'm going to show you later on, you're going to find out that it's so much easier. But maybe the first time or the first couple of templates you're going to create, you're going to add some comments into it. Like, why are we using this specific syntax? What is this resource actually doing? Or overall, maybe just a couple of lines of comments defining what the actual state of the deployment is going to be like. With this template, we're going to deploy a resource group, storage account, SQL database, virtual machine, 2 web apps in 2 different regions, and so on and so on. So you could also use it as a little bit of documentation if you want. So enough of talking and switching back to another demo. Where I can show you a couple of samples on what a Terraform syntax looks like. So the good news is that I'm still using the same Visual Studio Code. And as you can see, it's already picking up some updates, but I'm not going to run those because it might break my deployments in my demos for now. But that's the other thing where Terraform is like continuously being updated. Now, how does my VS Code know about this? It's because down here, I got my Terraform extension. It's a little plugin for Visual Studio Code like so many other ones, but it's capable of making your deployment smarter. Or even now, down here, it's telling me that Terraform version 12 is now also moving to experimental language. So what they are doing is actually making the language even more powerful, more intelligent. And again, I'm not going to push that update button, but it's triggered out of VS Code thanks to the extension I'm using, and I don't need to worry about anything. So it's just making my life, as I would say, a template creator so much easier. But back to the template itself, make it a little bit bigger. There we go. So what we have is, first of all, the comments. So whenever you start a line with the hashtag, it's allowing you to add comments. So without knowing anything about Terraform, all of you are probably capable in understanding that I'm going to create a resource group. Next to that, it's going to target the Azure credentials, Azure parameters, and I can provide a name for my resource group and a name for my location. Now, obviously, without knowing any language whatsoever, the assumption is that you still know enough about the backend. In this case, meaning that if you want to deploy an Azure resource group, you also need to know that the minimal settings you need to define is the name and the location for that resource group. Or picking up another one that's a little bit more complete is where I'm going to define the deployment for up here. Again, create a new resource group. But now the nice thing is that Terraform by itself is also smart enough to detect if the resource group is there. I don't need to remove it and picking it up again and redeploying it. So a little bit similar to what Azure Resource Manager is doing. Besides that, I can add additional parameters like tagging. It's a built-in Azure feature, has nothing to do with Terraform itself. Next, I'm going to create a virtual network. And again, the comment is super helpful there. But you can already see, at least I hope after just a couple of seconds, that the syntax is a lot more convenient. I would say it's almost plain English. Besides, again, hoping and assuming that you know enough about the cloud backend to support you in authoring the tools. So with that, you should have enough information to somehow getting convinced about why using Terraform. The syntax is a lot easier. The way of deploying is a lot easier. The language is a lot more straightforward. But next to that, it supports multi-cloud. So everything you can deploy with ARM templates out of Azure can also be deployed with Terraform. So there's no reason for not using it. Now, the starting point here is Terraform Providers. So remember the multi-cloud or multi-platform aspect of Terraform. The power of diversity, if you want, that comes in here is driven out of the Terraform Providers. So as you can see from the diagram, if I complete it, there we go. So from this diagram, what it means is you got Terraform as the automation engine, your infrastructure as code nerve center if you want. And from there, you have Terraform Providers to communicate with Azure. You got Terraform Kubernetes provider that's going to communicate with Kubernetes no matter where it's running. You got one for AWS, you got one for VMware, you got one for Hyper-V, for Google Cloud, and a lot of other components. And that's again what makes it easy. If you have a pretty good feeling with using AWS, you're going to use the AWS providers. If you got a pretty good feeling, or maybe later on after using Terraform for quite some time against AWS, and you're going to switch to Azure in a hybrid model or in a migration model, or technically the other way around to just be complete, then you just need to become familiar with the Azure providers and taking it away from there. And just another example here where on the left-hand side, I have a AWS Terraform template, and the right-hand side is an Azure Terraform template, where I'm just going to deploy a virtual network. So the first part is where you're going to specify the provider. So in your Terraform text file, you specify provider equals Azure RM or AWS or GCP for Google. And next you define a variable. So that's already targeting the actual resource provider where there's no difference. So if you've been using AWS, and obviously you should know that targeting a network resource in AWS is called VPC, and in Azure it's called VNet, but the syntax is 100% the same. So you could almost do find replace and reusing your AWS template and flipping it over into an Azure template. Everything else that follows is the data section and the resources section, where again, there's obviously some differences there because they're two different platforms, but the high level is almost the same. And depending a bit on the last part, depending a bit on what you're actually trying to migrate or deploy, I've seen some situations in the field where 85, sometimes even 90% of the HashiCorp language syntax is identical, no matter what cloud platform we're targeting. And it's almost, again, what I mentioned, find, replace, and obviously knowing what you're replacing and doing. But the high-level syntax, the skeleton, if you want, of the template file is the exact same thing. Now, looking at it a little bit more in detail, it's giving you the following HashiCorp language logic. So you always start with the resource type, and that's where you specify the resource provider, where in this case, I'm using the Azure RM resource group. That's the deployment of the service, and the resource type is the resource group. So later on, like I showed you already, if I want to deploy the network, I'm going to target Azure RM _ virtual network, the same for virtual machine, the same for app services, and so on. Next, it requires a descriptive name for the resource, and that's not really a Terraform requirement. It's an Azure resource provider requirement, where obviously you cannot really deploy the resource without attaching a name to it. And then again, based on the resource type, you also can define other configuration options. And that's how you're gonna alter your template. And then the outcome is what I showed you before. So we do have a section for the resource group, a section for the virtual network, a section for the subnet, public IP, network security groups. And again, it's just plain text if you want, a lot more intuitive. Now, outside of that, obviously, there's still the high level JSON-alike requirements, where if you miss any of the curly brackets to open and close a section, then it's still not going to work. And that's again where the VS Code extension for Terraform is coming in super handy, because it's going to warn you and tell you like, hey, watch out, there's a little syntax error here. So that's about the altering process, similar to what I talked about in the ARM introduction. But where it becomes super useful is the actual deployments. And this is one of the slides that I really, really love. So what's the idea? You're going to start with initializing the working folder. And I'll talk about it and show you in a demo later on what it means. Next, you're going to plan, which is described as the pre-flight validation, where it's going to cover your validation. So you start with initializing the provider. It's going to recognize, oh, with this template, you want to target the Azure platform, you want to target AWS, you want to target another one. Where next in the planning stage, it's going through your deployment template and validating if everything in there is actually correct. And then you're going to run Terraform apply, and that's where you're going to kick off the actual deployment. And then you take a little bit of time, and if you want, you can also run Terraform destroy, and that's going to remove what you actually deployed in the apply stage based on the planning validation. And that's it. So you run Terraform init, you run Terraform plan, you run Terraform apply, and if you want to get rid of the resources, you're going to run Terraform destroy, and it's going to pick up everything that you deployed before and removing it. I got a few more slides here for each and every step, but I'm quickly going to switch to a demo and showing you what it looks like. So the first part is Terraform init, where you're going to initialize what you're trying or what you want to deploy. And it's really the first command in any Terraform operation that you need to go through. So showing you what it looks like. First of all, it's just using a command prompt. If you open it up in PowerShell, would be the same. If you use the WSL, so the Windows Linux for Windows integration, that would also work. I'm running Terraform.exe because I'm on a Windows platform. If you want to run this on Linux or Mac, then obviously you need to download the correct application bits, and it's going to do the exact same thing. So even there, cross-development teams, if you want, is also supported. The way you're going to alter the Terraform files is the same on Mac, Linux, Windows, so making it again pretty intuitive. A couple of other options you have here is, for example, FMT format. So if you come from, again, the ARM template world and you're going to deploy them, then it's going to try to make the syntax a little bit more readable. Or if you sometimes grab some template files from the first version of Terraform that was not always using this nice looking syntax, you could also reformat them. So it's not going to change anything. It's just providing you a nice looking layout, which in the end should help you in understanding it. So from here, the next step is initializing it. And if you paid a little bit attention to my VS Code, you're going to find out that just to make it a little bit easy, I got a few folders where I'm storing my files. That's this one. So I got a Terraform file, and I also got a TF vars file. So let me switch back to my VS Code. And it might be better to just open up everything. So within my demo samples, that's just a folder. I stored this one little template file where I'm going to create a resource group. Now, next to that, I also have a variable file that luckily I'm not really going to show you. Why not? Because in there, I'm storing my credentials. So how does it work? Because obviously from my local machine, my Terraform needs to be able to connect to the Azure backend. So one of the options, the recommended options actually, is using a service principal. So the first step is out of your Azure environment in Azure AD, the identity space, you're going to create a new service principal. So think of a service principal as a service account that has the appropriate Azure permissions to deploy resources. And you could integrate them inside your actual template file, but again, sharing it with a team, it's not always the best practice from a security perspective to store your credentials hard-coded in the deployment files. And one of the options is storing it in an external file with variables. An even better option, for which I don't have time to walk you through in this 1-hour session, is storing it in Key Vault, which is the Azure secret store, and picking up the secrets from there. But back to my deployment. So what I can do from here is Terraform init and just pointing to my deployment folder. So I don't need to specify any specific template file, because what Terraform also supports is multiple deployment files. So if you have like a shared responsibilities or a separation of responsibilities, you could come up with a scenario where the network team is creating the network Terraform file, the database team is creating the Terraform template to deploy the database, and maybe developers are providing the template files for the web apps, Azure Functions, Logic Apps, anything else. You store all those files in the same directory, and Terraform is going to pick them up and deploying it. So from here, Terraform init, picking up the template file, and it's coming back with 2 lines of feedback: provider Azure RM with a version and provider random for deploying some other components. And it tells me initialization was successful, which now means that my Terraform instance is now up to date, smart enough to know that it's going to deploy something against the Azure backend. And then it tells me the next step is Terraform plan. And obviously using the same deployment state. And what it's going to do here is reading out. So it's communicating with Azure. It's validating my template file. And the outcome is that it's going to communicate with my Azure resource group, the one that I deployed already. Oh, that's the wrong one. This one, PDT Terraform. And since I already had it from my previous deployment, it's telling me if you want to kick this off and you're okay with that, it's going to be destroyed as well. So that's something that, for example, ARM templates are not really warning you about. And next to that, it's going to tell me there's one action. So plan 1 means I'm going to make a change to one item, in this case, the resource group. And there's one that's getting destroyed. So it's going to remove it and recreating just to set the scene. Or if I want to switch to Terraform init and using my demo samples too, so that's the longer deployment file with the VNet, the security groups, everything, it's going to be the exact same state, where now I can do Terraform plan. And that should provide me a bit more information about my deployment state. Where this time, since again, it's a longer deployment, but from previous sessions, the feedback was like, yeah, it's so easy to deploy a resource group. We can all do that. So I want to make it a little bit more challenging and walking you through a bit more complex scenario. So again, what it's going to do here is creating a whole bunch of Azure resources. And you can see for each and every resource at the end that as long as everything is green and plus signs, it means it's not available in Azure yet. So I'm going to deploy it. And then running the ultimate one, Terraform apply. It's going to read out the information from the previous planning state and validating once more. And next to that, I also need to confirm. Now you can make your Terraform exe syntax a bit more complete and avoiding that it actually asks you for confirmation, but just showing you what's happening. So it's again showing you the state, and the outcome here is that we got 8 new items to be deployed. And since this is a totally new deployment, there's nothing to be changed, nothing to be destroyed. And we're going to confirm, and my deployment kicks off. And it's already running. So it's, besides easy, it's also pretty fast. So the recap here, Terraform init, initializing, reading out the providers, which, by the way, if you don't have them installed already, it's going to grab them from the public HashiCorp website and downloading the provider engine. Next, we had Terraform plan, so running the validation, the pre-flight, creating an execution plan, validating if the template is correct, if the deployment will be successful, and also providing you output like an additional layer of validation. And then the last part was Terraform apply, and that's running the actual deployment. And as you can see, it's already done. So only takes a couple of seconds actually to just go out and deploy it. Now, obviously, it depends on what you're deploying. I'm targeting Azure West Europe, and partly out of the COVID situation and the huge demand of huge increase of demand of resources, I actually find out that deploying an Azure virtual machine is now finished in about 2 minutes, where before it took 5 to 7 minutes. But that's the deployment. So what was important is that Terraform State file. So we started with our deployment file. In this scenario, I call it the main.tf, but it could be any other file name as well. As long as it has the TF file name, it's fine. Where we ran the init plan deploy, and the outcome is a state file. And showing you some idea about this state file is this one. So it's a JSON output where it's going to provide me all the details from my deployment that I just kicked off. And it starts with the actual version of Terraform. So I'm using version 12.17. It's a little bit older. There's a newer one already, but not that important for my deployment. I deployed Terraform NIC with load balancer, public IPs, everything. I deployed network security groups. I deployed my load balancer and eventually my Ubuntu Linux virtual machine. So this is what I called using it for documentation. Now, whenever I make changes to my demo samples 2 option, that's where the state file comes in again, where before making any changes, like I showed you before, it's going to tell me like, oh, you made changes. I need to update 4 resources and maybe destroying 2 of them. So it's again a validation file that it's going to use for future deployments. And then moving to the last part, I got about 10 minutes left, so perfect timing, is what I call the best of both worlds. So what I mean by that is, first of all, that Terraform is part of Azure in a couple of different ways. First of all, if you're familiar with Cloud Shell, if not, I'll have another demo ready to show you, is that now I was using Terraform for my local machine, but you could avoid that step and you don't have to install anything. So you could run all this automated deployments from the browser. Next, and that's where it becomes really interesting, is that you can recognize, integrate your RM templates. Imagine that you've been using RM template deployment for quite some time, where now you can integrate your 100% RM template syntax as part of a Terraform template. So imagine that you got multiple worlds where maybe the developers are already using Terraform, but you're coming in from an Azure mindset with ARM templates, then nothing would block you from actually opening it up and combining the 2 worlds together. And then last, what I'll show you in the last demo is deploying everything in a full end-to-end CI/CD pipeline model using Azure DevOps. So the process is the same. We start with a Terraform deployment file where we're going to reuse everything from the Terraform syntax and at the same time squeezing in 100% RM template syntax running through init, plan, deploy again, and eventually having a successful deployment. And the setup would be this one. So I start with some Terraform syntax here on top. So similar as my previous deployment, come on mouse, communicate with the Azure backend and create a resource group. And once you have the resource group, within, we're gonna run Terraform syntax template body deployment. And in here, from line 11, all the way down to line 65, that's an ARM template. That's the exact same template that I used in one of my first demos on how to deploy a storage account. So I'm just picking up the template. Another option is, instead of copy pasting it in meantime is actually pointing to your ARM template file. And that would also be a possibility there. And then closing again with some other specific Terraform syntax, where even this time, my storage account type is defined as standard GRS out of Terraform syntax again. So it's really recognizing and bringing the two worlds together. So from here, I could run Terraform init ARM sample. It's again telling me up here I'm connecting to Azure, where this time it's using version 137, so that's an older one because it's defined like that in my template. And it tells me that maybe it's a good idea to move to an upgraded version, which again, I'm not gonna do because I don't wanna break my template deployment for now. Next, Terraform plan. Oh, that wasn't expected. Maybe it's about time to actually do my upgrades, but since I only have about 10 minutes left, I'm not gonna do it. But obviously from here, let's see what happens. It's gonna tell me like, you need to fix the problem. So what I'm using here is some newer syntax, and that's where the VS Code already warned me about, that I'm using certain parts in my template, Terraform syntax, that are not recognized anymore because of my older version. So just showing you a little bit that although everything might look shiny and cool, that it's obviously a continuous work in progress, that Terraform is improving, Azure is improving, and that's, I would say, welcome to the cloud world. The last part is Azure DevOps. Now, even if you don't know anything about Azure DevOps, easy said it is CI/CD pipeline and a lot more than that. And if you have no idea what CI/CD pipeline is, it means end-to-end automation deployments for about any application workload you can think of. The main idea with CI/CD pipelines is that you're going to run a build validating the source code. And once the build is ready, you're going to hand it over to a release process. And we can do the exact same thing with Terraform. And if I zoom in a little bit on the screenshot, but I do have some time to walk you through the actual scenario, is a combination of standalone tasks. So Azure CLI, where next to 4 Terraform logos are showing up, where I'm going to do an install of Terraform against my DevOps build servers, running Terraform init, plan, and that's pretty much it. And the outcome is a deployed application. If you already use a DevOps way of working outside of Azure DevOps, so if you use Jenkins, you could do the exact same thing. If you already use it without Terraform, then it's just another part of the chain. So you would start with developing in the middle. You're the developer or the engineer, cloud engineer. You might use VS Code, maybe use Visual Studio or another development environment to create your deployment templates, integrating with source control to modify the versioning from the templates and keeping track, and pushing them through the continuous integration, continuous deployment. And the outcome is, out of your Terraform integration, it's going to pick up the template files and running the actual deployment. So the process is 100% the same, single cloud, multi-cloud, in Azure, outside of Azure, it doesn't matter anymore. It's really that intuitive. And what it comes up is my Azure DevOps environment, where I have a Terraform sample project. I got Azure repos. It's the DevOps integrated source control. So if you're familiar with GitHub or Git Enterprise, that's somehow Azure DevOps integrated replacement. In here, I got a little Terraform file where I'm going to deploy my web app. So similar to what I showed you before, and that's where we can make it even more intelligent. Like if you want to use Terraform, this template is a bit smarter than what I use on my local machine, where I'm forcing a specific version of Terraform. Why? Because in this template, I'm using some newer capabilities, like the feature parameter. That's something new in the newer version of Terraform, which is not available in the previous versions, which means that if I'm running this Terraform template on my local machine with an older version of the Terraform engine, it's not even recognizing those settings and obviously not running the deployment, as you could see before. But everything else is just a regular Terraform template. So next you create a CI pipeline. So that's the build stage. And in there, that's where you go back to the source control, picking up and running it, validating it, and eventually going to run a release, like push it out to production. Come on. The GoToMeeting doesn't like my mouse for some reason. And that's where we're going to specify our pipeline. So most important is the Terraform steps. I'm also doing some other magic with Azure command line, but not that important for my deployment here. So I inject a task that when this pipeline is running, it's going to install Terraform version 0.12.3, which for now was the latest one. Next, I'm running Terraform init, where it's going to pick up the Azure artifacts from my source code. It's running Terraform plan using the same source files, and eventually running Terraform apply. And this time it's literally adding the auto approve parameter to make sure that nobody needs to wait for the actual deployment. And the outcome of that is my Terraform resource group, where I deployed my application, my app service plan, which is an Azure web app requirement. And if all goes fine, I got my web app up and running. This could be VMs, this could be Azure, this could be or SQL Azure, this could be anything. So that's end-to-end CI/CD deployment. And with that, we have a couple of minutes left, so perfect timing, where I'm going to check the notifications. There's a few questions coming in apparently. So some feedback about the deployments where everything would have used AZ instead of Azure RM. I didn't really show anything on that part, but it's correct where out of the PowerShell deployments, you can use AZ deploy or Azure RM deploy. It's still valid, but about a year ago, that got actually updated, but the two languages or syntax are still valid. Okay, so it was more like a comment and not really a question, but perfectly fine. Don't know if there are any other questions. Apparently not for now. So I'm going to close it down in the same way as I started. So I introduced you to RM templates, a little bit introduction maybe or a recap for some of you. Then we talked about what is Terraform, like what is HashiCorp as the organization, why using the tool and what are the benefits, mainly compared with built-in Azure native ARM templates. I walked you through the Terraform basics, most important, Terraform syntax file, init, plan, apply, and that's kicking off your deployments. And then combining the best of the two integrations together, Azure benefits, ARM templates, injecting in your Terraform templates, and lastly, showing you how you can integrate in your existing CI/CD pipeline.